Okay, we have here another fun integral sent to me by Sid. We have the integral from 1 to e of natural log of the x to the 1 minus kth root of x dx. Okay, I think most of this problem is really about just sorting out this because it's pretty unfamiliar to see like an unknown in the root like that. If this is confusing, just think like, okay, if you have the third root of x, we can always write this as x to 1 over 3. So doing the same thing with what we have here, I can just rewrite this as x to the 1 over x 1 minus k. But then for this exponent, this still looks confusing, but what we can do is flip it and change the sign. So I can write this as x to the k minus 1. And so I think that's a little better, and let's remember what we have here. We have this inside the natural log. So this is natural log of x to the k minus 1. And with log properties, I can bring this out front of the natural log. We don't have to worry about the sign on this because our x values are always between 1 and e. So what I can do is bring that out front. We have x to the k minus 1 times natural log of x. So I think writing it like this, it's going to be a lot easier to deal with it as an integral. Let me put this back in the integral, and I think we can continue using integration by parts on this. Okay, so for integration by parts, I've set up our table for the DI method over here to the right. I'm going to differentiate natural log x, integrate this x to the k minus 1. One note on this, you could do a u substitution for ln x. Sometimes it helps with integration by parts, but in this case, the integration by parts is pretty simple, so I'm not going to bother. Okay, so to go ahead with this, let's first differentiate natural log x. That's going to be 1 over x. Then integrating here, this is just power rule, so we integrate, we get x to the k over k. So we have part of the solution on the diagonal. Let me write that down. We'll write it as x times k natural log x over k. I'm not going to try to evaluate it yet. Let's evaluate everything at the end. So then this last row here is going to be an integral. I'll take the 1 over k out front as a constant, and we're integrating here from 1 to e. When I divide x into this, we're going to get back x k minus 1 dx. But then this integral right here, this is just going to be power rule again, so we can integrate this. I'm just going to get a little space here. So first, let's copy down this part from over here, x to the k, ln x over k. Then here, power rule, adding a plus 1 on here, this is going to become just x to the k. Take the k out in the denominator, we just need to evaluate from 1 to e. Before we evaluate, let's just combine these, multiplying 1k times 1k. I can write this as a k squared here. Plugging in e, we're going to have e to the k. ln of e is just 1, we'll leave that off, and it's going to be over a k, minus, plug e in here, that's going to be another e to the k over k squared. Then for the next part, plugging in 1, when you plug 1 into natural log, that's going to be a 0, so this whole first part's going away. Then here we're going to have a minus sign, 1 to the k is just 1 over k squared. Minus times minus is plus. Let's get a common denominator over here, so everything has a k squared in it. So if I multiply by k over k, here like this, I can put this together with a common denominator of k squared for everything. Factoring out an e to the k here, we have e to the k times k minus 1 plus 1, and that's it. Okay, so pretty unique problem having x to the 1 minus k in the root. Not too difficult, but still pretty interesting. Thanks to Sid for sending it. Thanks everyone for watching. Have a good day.